Hi, my name is Joe Whalen. I'm a systems engineer with NetApp, and today we're going to do an intro demonstration of Clustered ONTAP 8.2. And next slide, we'll talk about all the capabilities that we're going to demonstrate today. So today we're going to create a two-node cluster within Clustered ONTAP. We're going to create an aggregate or a pool of storage. We're going to create a storage virtual machine, which is the backbone to Clustered ONTAP. It's a virtual representation of a physical controller. We're going to create volumes both for CIFS and NFS access, and then we're going to mount both the CIFS and NFS volumes from a Windows client and from a Linux client, respectively. And lastly, we're going to create two LUNs. We're going to create one for Windows and mount it from a Windows client. And we're going to create another one for Linux, and we're going to mount that from a Linux server running Red Hat Enterprise Linux. So here's a diagram of the lab that we'll be doing our demonstration from today. So the jump host, that's at the top left-hand corner, that's our Windows 2008 server that we'll be remote desktoping into. That's where we're going to do a majority of our work is in terms of accessing CIFS shares and presenting a Windows LUN. We're also down the bottom, you can see there's a Red Hat pair of Red Hat servers that are down there running Enterprise Red Hat Linux. We also have an on-command unified manager as well as a virtual domain controller as well. All of these connect into the network as well as two pairs of ONTAP FAS simulator clusters, and these are going to be the systems that we actually join together during our demonstration today. These pairs are joined together by a 10 gig backbone, and that's the cluster network on the far right hand side. So we're going to start by opening up a Putty session, which SSHs into our first unjoined node. We're going to log into that node now. So we're going to start by running the cluster wizard. So we're going to run cluster setup. First option is going to be to actually create a cluster because one does not exist right now. We're going to say no, we don't intend to use this as a single node. This is going to be a pair. We're accepting the defaults for the E0A and E0B interfaces for the dedicated 10 gig backbone. Now it's asking for the cluster base license. So we're just going to be doing some copy and pasting of licenses, both for the base license and some of the supporting protocols such as CIFS, NFS, iSCSI, Snap Restore, and the Snap Manager bundle. Just to make things easy, we're just going to copy and paste the keys in as appropriate. So now we're at a point now just to add the additional license keys in for all the additional protocols. And these are just demonstration licenses for each system that you would purchase. Each physical FAS device would have its own unique key. So we've entered all the keys in. We're going to accept E0C as the cluster management interface. So we're going to accept that as a default. So we're going to enter the IP address. So these are addresses that have been handed out to me from our lab folks. So we're going to go with 0.101, 24-bit subnet mask, and 0.1 gateway. Our domain name is going to be demo.netapp.com. And we'll enter the IP address of the DNS server, which is 0.253. You can enter physically where the controller is located. Again, the node management interface we're going to keep on E0C. And there you go. So the first node is joined. All the IP information is in there, and that's all that's really involved in setting up that first node. So we're just going to do a cluster show here, and you can see that unjoined 1 is now in a healthy state. One thing we're probably going to want to do is we don't want to keep it named unjoined 1, so we're actually going to do a node rename command. So node rename dash node unjoined 1, which is the current name, dash new name, and we're going to put the new name as cluster 1-01. That job's now in queue. That's completed, and just to make sure it works, we're going to do a cluster show. You can see the new name's updated. So now we're going to take unjoined 2 node, and we're going to join that into the first node that we just joined into the cluster. So the main difference here is as we log into the second node, instead of doing a create, now we're going to do a join. So again, we go into the cluster wizard by typing in cluster setup, and here we're going to type in join. We accepted the defaults. Again, E0A and E0B are for that 10 gig dedicated backbone network. We're going to join the cluster 1 cluster. So we'll accept that default. Setting up the network for us, checking to make sure the cluster is healthy. Now it's starting up the cluster. So again, we're going to accept E0C as the management interface. Again, this IP information has been given out to us from our lab folks, so we know that we're all set there. And that's it. So again, we're going to do a cluster show. We're going to make sure that we should see both nodes now in a healthy state, which they are. Again, we're going to want to rename unjoined 2, something a little more logical, so we're going to call that cluster 1-02. The same command, node rename dash node, the old name, and then we're going to enter the new name here. Job's queued up. It's complete, and again, we're going to do a cluster show just to make sure it's healthy. And the last thing we're going to do here, just from the command line to show you how to do it, is we're actually going to do an aggregate show. And you can see that the aggregate name for the second node is kind of an odd name, so we're going to actually rename that. So very similar to how we renamed the cluster node, we're going to do an aggregate rename command. We're going to call that something a little more logical. And what we'll do is, in the next section here, we're going to rename the first aggregate via the GUI, but we just want to show you how to do it via command line here. Oops, had a typo there. There we go. So job is queued up. It succeeded. Now we're just going to do an aggregate show, and you can see the aggregate's been renamed. And we'll show what that looks like via System Manager in just a second. So now we're going to sign into OnCommand System Manager. So pretty much from here on out, we can do everything through a GUI instead of command line. It's really just that initial setup of the nodes that we have to do via the command line. So now we're putting in the management IP of the cluster, or can we even just use the cluster name since it's going to resolve. We're going to pop in the admin credential so it remembers it for us. We'll just check save my credentials so next time it'll remember. So if we go into the aggregates section under the cluster, we can see that we have the renamed aggregate that we did via command line. What we're going to do is we're going to go to Agger0, and we're going to actually edit the name just by clicking on it and hitting the edit button. We're just going to highlight that name and type something again to match the same flow of the one that we did via command line. So ag0 underscore cluster1 underscore o1 underscore 0. We just hit save and close. And you'll see that name gets updated once this closes. And there you go. So we're going to go into System Manager, and we're going to create 2 new aggregates, one for each node. So under the cluster window, we're going to highlight aggregates, and we're going to hit create. It's going to open up the create aggregate wizard. We're going to name the new aggregates to match the same naming convention that we previously used, except this time it's going to be ags1 instead of 0. And again, we're going to do that for each node, so cluster underscore O1 and O2. We're going to select disk. Each node's going to have 13 virtual disk available, so we're going to choose 6 for our demonstration today. We're going to hit save and close. We're going to hit create. And that aggregate's created. Now we're going to do it for the other node as well. So we're going to have each node's going to have a root aggregate where the operating system files reside, and then each one will have a data aggregate, which will be ag1 for our lab today. Again, you're going to select disk. This time you're going to choose the second node, and you're going to reduce the disk count down from 13 to 6 for our lab today. It's creating that second aggregate. It's finished. And here you can see, just in the aggregate view, all the aggregates that we created, ag0 and 1 for both nodes. So now we're going to actually create a VServer for our our NAS protocols for CIFS and NFS. So we're going to go to the VServer tab on the left-hand side, and we're going to hit the Create button. We're going to call our VServer VS1, and you're only going to see the protocols that you're licensed for, which for our lab today is CIFS, NFS, and iSCSI. Since we're just doing NAS protocols today, we're just going to check CIFS and NFS. We're going to do NTFS security, We see the domain and the DNS server. We're going to accept that as the default and hit save and continue. So we're going to enter in the IP address that's provided for our lab today, which is 192.168.0.131. Again, we're going to do a 24-bit subnet mask and a gateway of 0.1. The home port, which is what we're configuring here, is going to be on cluster 1-1-01 home node, and we're going to use E0C as the home port. And this basically joins the Active Directory domain just like any server would. We're typing in demo.netapp.com. It's going to go to the default computers OU. Server name is VS1, and we're going to give it basically an administrative password. So at this point, it's creating a CIFS server. It's joining the domain, providing we gave it the proper credentials, which we have. We're also going to create a VS admin account. So this is basically an administrative account only for the VServer. So nothing outside of the VServer world. Okay, so we're going to submit that and continue. We're going to hit OK. And you can see here our VServer now has both the NFS and the CIFS protocols licensed and configured. So now we're going to go to the configuration, and we're actually going to look at our network interfaces. And you can see right now that we have one LIF, one logical interface configured, and that's on cluster 1-01. What we're going to want to have is a second LIF configured on the other node within the cluster. So we're creating an interface. We're going to select it for both data and management. We're going to use the same naming convention that we used for our first LIF. It's always good to name your LIF something that's logical. If it's for CIFS and NFS, to incorporate that into the naming convention. And because our vServer is only set up for NAS protocols, that's all we have the option to check. This time we're going to browse for our home port, and this time we're going to select the second node. And again, we're going to use the same E0C port. And this time we're going to use the IP address of 192.168.0.132. And again, 24-bit subnet mask and a gateway of 0.1. We're going to hit next when we're done. And once this completes, now we have our vServer set up. We have two LIFs, one on each node for redundancy and resiliency. And we see both LIFs listed there. So we're just going to take a quick look at the CIFS and NFS configuration. So we're going to go into the protocol section under configuration. We'll click on CIFS. We can see it's started. It's VS1 is the system name. It's joined to the Active Directory domain. And we joined it to demo.netapp.com. So we're going to click on NFS. We can see server status is enabled, which means all the services are properly started. Currently we have NFS 3 enabled. So now we're going to go into policies and click on export policies, which is for NFS. You can see the default policy is set up. So what we're going to do is we're going to add a rule for that. And what this rule will do for us is we're going to create a single access rule that basically grants read, write, and root access to any node on the network without regard to which NAS protocol it's using. And like I said, this is just something for demonstration purposes, just opens up a wide open policy, not something you would typically want to do in your environment. So now we're going to go into storage and then shares. You can see the two default admin shares that exist. We're going to create a new one. So right now the only folder that we have available to share is the root volume itself. So we're going to click on that and hit OK. We're going to create a share called share1, and we're going to hit create. So now we're going to hit edit on that share, and you can see we have the ability right from here to edit the ACLs on the share itself. So right now it's open up to everyone full. We also have various options that we can change. One I always like to enable is to be able to show your snapshots, which is basically a tilde snapshot directory that is read-only. Gives users the ability to do their own restores. Some administrators do not care to have that option checked, so you have that option on a share-by-share basis to turn on or off. Another thing we're going to look at here are local users and groups. So this is where you can do a mapping of Unix users to Windows users and vice versa. So we're going to show what that looks like. So we're going to add a Windows to Unix rule. So basically, Windows to Unix means for any demo administrator account, that's going to have the equivalent access to the root user. And vice versa, we're going to set up another rule of Unix to Windows, which does the same thing. So if you're logged in as a root user, you would have the same access that the demo administrator would as well. Typically, you're going to want those accounts to have the same level of access. There you go. And now you've mapped the local domain, local root user to the domain admin user. So now we're going to create a couple volumes, vol 1 and vol 2. And what we're going to demonstrate is this whole concept of namespace and junction points within clustered ONTAP. So we're going to create a new volume within the first data aggregate on node 1. So we're creating a 1 gig thin provisioned volume called vol1. And if you look under the namespace tab, you can see that immediately becomes a child of the root mount point. So we're going to create a second volume. We're going to call it vol2 of the same size, 1 gig in size. We're going to thin provision that as well. Also going to tie that to ag1 on node 1 and thin provision that as well. And again, what you'll see is it automatically will mount itself under the root volume. So what we're going to do here is we're going to play around with the concept of unmounting and remounting volumes as different junction points at different levels with different names. So you can see we just unmounted vol2. So now we're choosing vol2 as a new junction point, and we're actually going to call it projects instead of vol2. And instead of mounting it under the root volume, we're actually going to mount it as a child directory of vol1. So this now gives us the capability to build our structure however we see fit. So now what we'll do here is we're going to play around with this idea of CIFS shares and accessing our data via the CIFS protocol. So we're actually going to map a drive to that share1 volume that we shared out earlier. So we're going to do / vs1, which is our VServer name, /share1. We're going to map that to the Z drive. And once that mounts, what you're going to see is you're going to see, because that's the root volume, you're going to see vol1 as a folder, but we actually know from the work that we just previously did that is actually a volume in NetApp. So that's not even deletable. It is a read-only directory. And basically all these junction points just represent themselves as folders under each of these shares that are out there. I have the capability of creating a file, just doing a quick little write test just to show that I have the ability to create a file and save it to that directory structure. And I'm able to save my work. And now we're going to do the same thing in the Linux world. So what we're going to do is we're going to open up a Putty session to one of our Red Hat servers. We're going to choose Red Hat 1. And we're going to log into that with root credentials. We're going to create a directory VS1. We're entering the commands to allow us to actually mount that VS1 share as a NFS Mount Point. Now if I do a DF, I see VS1 now. I'm going to change directory right into VS1. And if I do an LS, again, I'm going to see the CIFS.txt volume, the CIFS.txt file that I created, and I'm going to see vol1, which is the directory that is a mount point under the root volume. So even though we're coming at it through a different protocol via NFS, we're seeing the same thing that we did in the Windows world, right from Linux. And if I change directory to down one level to vol1 and do an ls, I see that projects mount point, which is actually a vol2. And we renamed the junction point projects. So from a directory perspective, all I'm seeing is the actual word projects as a folder, as a directory. So we're going to go back up one level to VS1. I'm just going to show that I can read the CIFS.txt file. Now I'm going to write my own file out the same directory right from the Linux host via NFS. And we're just going to cat that just to make sure we can read it. There you go. So what we're going to do now is we're going to create another VServer, and this time we're going to create it for block level access. In our lab, we don't have fiber channels, so this will just be for iSCSI. So we're going to call it VS-LUNs. We're going to check the iSCSI protocol only. Again, so we're going to accept the defaults here. We're going to choose the first node of the two nodes in a cluster. We're going to accept the DNS information that's in there. We're going to hit save and continue. Okay, and what we're doing here is we're specifying how many lifts per node that we're going to want to designate, and we actually give it a starting IP address. So according to our lab sheet, the IP address range that we have to work with here is going to start with 192.168.0.133 with a 24-bit subnet mask and a gateway of 0.1. I'm going to hit submit and continue. Again, we're going to create a VS admin account, which is just an administrative account to this vServer only. So this would not have administrative rights over VS1 that we created earlier. This would be just for VS-LUNs vServer. We're also going to create a management LIF for this vServer only of 192.168.0.137. And again, we're going to use E0C for that purpose. We're going to see the summary information. We're going to hit OK, and you can see this vServer is set up for iSCSI only. So what we're going to do now is we're going to create the LUN to attach to the Windows host. So one thing we're going to want to do is we're going to want to come into the iSCSI initiator properties, and we're actually going to want to get the initiator name from the jump host that we're using that we're going to present the LUN to. So we're just going to copy that for later. Okay, so now we're going to go into our VS LUNs VServer, and then we're going to go to the LUNs section. And we're going to say create a LUN. And at the same time, we're going to create a volume at this while we're going through this wizard. So we're going to call our LUN something a little logical for a Windows LUN. So we're going to call it windows.lun. We're specifying that it's a Windows 2008 or later operating system. And that's just for the block alignment. Just going to create a 200 meg LUN, very small, and we're even thin provision it. We're hit next. So we get the ability here to actually create a volume while creating the LUN. So we're going to pop in and we're going to choose, again, the first data aggregate on node 1. So now what we need to do is we need to add an initiator group. So again, we'll call it something somewhat logical for a Windows initiator group. And we're going to choose the port set. So we're going to accept the default, which has all the iSCSI lifts that were created during that setup process that we went through when we set up the vServer. So we're going to accept that. So we see all 4 lifts. We're going to give the initiator group a name. Then we're going to go to the initiator tab, and this is where we're going to enter the initiator name that we took from the jump host. So we're going to hit add. Should be able to copy and paste. Whoop. Delete that. We're going to highlight that. We're going to copy. Control V. There we go. We're going to hit OK. We're going to hit create. Saying it successfully created the initiator group. We're going to hit OK. We're going to check to actually map it because it has not actually mapped the LUN yet using that I group. It's only created the I group. We're going to hit next, next, and this is where it actually does the work and actually maps the LUN to the host. We're going to hit finish, and at this point the LUN is actually mapped to the jump host. And now we're going to do something with it in the next section. And you can see the LUN right there. So now we're on the jump host again. And what we're going to do is we're going to set up the LUN. We're also going to make sure all the multipath information is set up correctly. So we can actually go into MPAO properties. If this was not grayed out, that would mean that multipathing is not set up properly. But because it's grayed out, we actually have the drivers already installed. If they weren't installed, we would install it and then have to reboot the host. So we're going into the iSCSI initiator properties. We're going to the Discovery tab, and we're going to click on the Discovery portal. So we're entering in the first IP address of the first LIF that we created, and we know there's 3 more. So we're going to go back to the Targets tab. We're going to highlight the inactive session and hit Connect. We're going to check the Enable Multipath checkbox and go into the Advanced Settings. And for Target Portal IP address, we're going to choose the drop-down box, and we're going to make sure .133 is selected. And we're going to hit OK. We're going to hit OK out of that. And you can see the status is now changed from inactive to connected. So what we're going to do now is we have one path set up. We want to set up the other three. So we're going to highlight that. We're going to go to properties. You can see that's the one session that's active. So we're going to add three more. So again, we go to add session. We're going to enable multipath. We're going to go to advanced. For target portal IP, we're going to do the same thing, except this time we're going to choose .134. We're going to hit OK. Hit OK again. And you can see a second session is in there. So now we're going to do that for .135 and .136 as well. And what you'll see is we now have 4 sessions, 2 sessions per node, which is the minimum that we want per node just for resiliency and redundancy. You hit OK. We're just going to close out of this. So what we're going to do next is we're going to go into Server Manager. We're going to go to the Storage section. We're going to go into Disk Management, and what we should see now is we should see one LUN being presented, and it immediately wants us to initialize that disk. So we're going to initialize it using MBR. Then we're going to actually right-click on that unallocated disk, the one that's set at 203 megs right now. We're going to do a new simple volume, and that's going to open up the wizard. We're assigning just the E drive. Just going to do a quick format. Again, we can call it something that's a little more logical. We're going to finish. And now you have an E drive. Like I said, the data is fully accessible at this point. So one thing we're just going to want to check to make sure all the multipathing is set up properly. We're actually going to right-click right on that disk. Go into Properties. We're going to go into Hardware, and you're going to see NetApp LUN C-Mode Multipath Disk. So what we want to do there is we actually just want to click on Properties. And now we're going to go to the MPIO tab, and you can see all the active and optimal paths and non-optimal paths. So this is all the ways that data can be accessed from the host all the way to your storage array. So you just want to make sure that you see all the paths that you have defined. And again, for us, there should be 4 paths there. So now what we're going to do from System Manager again is we're going to create a LUN manually here. And we're going to do it for the Linux hosts that are out there. And it's going to be pretty much the same process on how we created the LUN for the Windows host, except we're going to make sure we choose Linux instead of a Windows OS. And again, that's for proper block alignment, so you don't have any kind of misaligned LUNs. Same thing, we're going to do a 200 meg LUN that's thin provisioned. We're going to create a new volume, again on node 1, data aggregate 1. We're going to add an initiator group. The port set, again, will be all 4 lifts that we have defined for that VServer, so 2 lifts per node for resiliency and redundancy. We're going to go to the Initiators tab. This time I actually copied the initiator So we should be able to paste that right in there. There we go. We're going to create that. The iGroup is successfully created, so we're going to hit OK on that. Again, we have to check that box. It is not mapped yet. We've just created the iGroup. And once we hit next, this is where it actually does the mapping. And at this point, that LUN should be fully mapped to our Linux host. And what we're going to do is we're going to hit finish here. And we just verify that the LUN was created. Now we're going to hop on the Linux host and verify. Okay, so now we're going to putty back into the first Red Hat server. We actually already had a session open from our previous work, so we'll just use that. We're just going to check some of the packages that are actually installed on this Linux host already. So we're going to just change back to the root directory. And keep in mind, too, all this work that we're doing, both in the Windows and Linux environments for block level access, there is software out there that we sell called Snap Drive, and it does automate a lot of the things that we're doing a few manual steps for. So, from the host side with the proper credentials, you can do everything right through a GUI without having to first create it on the storage array and then manually do the formatting at the host layer. So that's some additional capability through the SnapDrive software. There's SnapDrive for Windows, and there is SnapDrive for Unix. Today, for this just demonstration, we're going to show you basically the way of doing it, both creating on the storage array and then doing the formatting at the host layer. But understand there is some additional software to kind of make things a little easier in terms of formatting and getting everything up and running more quickly. So we're just checking some of the settings here, some of the iSCSI settings, to make sure that we're all set up properly for iSCSI connectivity to our Red Hat host. And we're just checking to make sure we have all the correct packages installed on the Linux host. And that's just a way of checking your multipathing settings for this Linux host. You can see that it's set up with a Lua. So what we're doing now is we're checking the iSCSI service, and you can see that it's stopped. So now we're going to start the service up. You can see it started up, and just one more time, we'll do a status. So it started up and just saying that currently there's no active sessions. So now we're basically scanning to find any iSCSI LUNs that are out there. Now we see all these LUNs that are available for us. And the reason that we're seeing those is that we did the appropriate LUN masking in our last section. Just had a typo there. And those are all the sessions that now exist. SandLun is actually one of our tool sets. So this will actually show you the path from a NetApp perspective on what we're mapping to. So really helpful tool to help us figure out how to access our data from the Linux host. So you can see the multipathing daemon is not started, so we're starting that now. We're doing a status. Now you can see the process that's running. So it's doing a check config. And we're going to need this setting when we actually go to map the LUN. Okay, so now we're set to actually map the LUN and get everything configured for our final stage here. Okay, so now we're doing our make fs command. We're going to use ext4 as our file system format. So it's now formatting the files with file system. We're actually going to do a make directory /Linux LUN. And we're going to mount it. And we should be able to do an ls on the Linux LUN. There you go. So just to test, we're going to just write a quick little hello command to the LUN that we just created. And if we do a cat, we should see that file in there, and we should see it with the text of hello. Oops. There you go. So you see we created a file, we presented the LUN, we formatted it with ext4, created a file, filled it with text, we were able to save that. And again, we can do an ls-l on that LUN and see that file. And that's going to be it for our intro demo today for Clustered ONTAP. Please check out our advanced demonstration, which will get a little more deeper into more of the advanced functionalities of CDOT. Thanks for your time, and I hope this was helpful.